This is the problem we're looking at. Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Clementine is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system of equations to find how long before they have volunteered the same number of hours. We want to start by looking at Jared. He has volunteered 50 hours. And this is before he starts volunteering 3 hours each week, right? And then after he has 50 hours of volunteer hours, now he's going to volunteer 3 hours in every upcoming week. Now Clementine is a new volunteer who has not volunteered any hours. And he is now going to volunteer 5 hours each week. This is moving forward. All right, so that's the situation. We have Jared and we have Clementine. And so when we're answering this problem, the first thing we need to do is the same as with any word problem. We need to define our variables. Right? So we're going to define x and define y. So let us say, let x be the number of weeks. Right? And then we are going to let y be the volunteer hours. So we have our x-axis is the number of weeks, and the y-axis is our number of hours. Right? So if we're going to make so let's go ahead and draw this out actually. We have an x-axis and a y-axis. So our x-axis is going to be weeks, and the y-axis is going to be hours. So with Jared, he has volunteered 50 hours at 0 weeks. Right? He has 50 hours before he even starts saving. So that is our y-intercept. That's Jared right there. Right? And every week he's going to increase by 3 hours. So 1 week passes, and he's going to bump up by 3 to 53. 2 weeks pass, he's going to bump up to 56, and so on, right? And so here is Jared. And then we have Clementine, who's a new volunteer. Right? At 0 weeks, he has 0 hours. Right? He's new. He has no hours saved. And then he's planning on volunteering 5 hours each week. So after 1 week, he's going to be at 5 hours. At 2 weeks, he's going to be at 10 hours. Right? And so over here, this is Clementine. So up here, this is Jared, and this is Clementine. So now we need to go ahead and write those system of equations. Okay, so let's start with Jared. Right, the number of volunteer hours y for Jared is going to be equal to the rate, the slope, right, that Jared's line is at. And his slope, his rate, is 3 hours per week. So it's 3 over 1. And then let x be the number of weeks. So it's going to be 3 per week. 3 times the number of weeks x. And then we have our y-intercept for Jared. And our y-intercept is going to be how many hours he has saved before he starts saving. And it says here in the problem that he has 50 hours. He has 50 hours at 0 weeks. Right? And then he starts saving hours each week. So that's our y-intercept. Great. So we have our equation for Jared written. Now, what's our equation for Clementine? It's y is equal to, and the slope for Clementine, right, the rate for Clementine is 5 hours each week. So it's going to be 5x, 5 times the number of weeks that he is saving. Then we're going to add the y-intercept. We're going to add the number of weeks that he has saved, that he has before he starts saving. And you can see here when weeks is 0, Clementine's hours is 0. So Clementine's y-intercept is going to be 0. Right? And so this is our system of equations. And so now we want to take a look at it and say which method is the best method to solve this system of equations. And so we're looking here, and we have graphing. That's when you don't want to give an exact solution, but we do want an exact solution here. Substitution, if one of the variables has a coefficient of 1 or -1. And I think that's a great method to solve this system of equations, because here we have our variable y has a coefficient of 1. Not only that, but it's solved for, and so we can just go ahead and substitute and solve for x. So let's go ahead and do that. Let's apply substitution here. And so let's substitute 5x instead of y in the other equation. It's going to become 5x is equal to 3x plus 50. Then we are going to subtract 3x from both sides of the equal sign. And we'll get 2x is equal to 50. We're going to divide by 2 on both sides of the equal sign, and we'll get x is equal to 25. And what is 25? Well, what is x? Right? Let x be the number of weeks that these people are saving. Jared and Clementine. So the answer is they will have the same hours in 25 weeks. And that's what we're going to put our box around. Alright, great. So now let's go ahead and take a look at question number 12 on 376. So question 12 is here. And it says, for the Future Teachers of America fundraiser, Denzel sold food as shown in the table. Pizza for $5 each, subs for $3 each. He sold 11 more subs than pizzas and earned a total of $233. Write and solve a system of equations, then describe what the solution means. Okay, so we're going to need to extract two equations from this line here in the table. He sold 11 more subs than pizzas, and he earned a total of $233. All right, so let's go ahead and come back to our worksheet. Zoom out a bit. And the first step to any word problem is always the same, is to define our variables. So let's go ahead and say let x be the number of pizzas he sold. Be the number of pizzas sold. All right. Then we're going to let y be the number of subs sold. Alright, there we go. So now what does it say? The word problem says he sold 11 more subs than pizzas. Alright. So what can we say? The number of subs he sold, y, is equal to the number of pizzas he sold, x, plus 11. Because again, the problem states that he sold 11 more subs than pizzas. Alright, so that means the number of subs he sold is the number of pizzas he sold plus 11. Alright, now our second equation is going to be with respect to how much he earned in total, which is $233. Alright, so in this case, the amount that he earned selling pizzas plus the amount of money he earned selling subs equals 233. So how much did he earn selling pizzas? Well, he earned the number of pizzas sold times how much each pizza cost, which is $5. 5x is how much he earned from the pizzas. We're going to add that to how much he earned from the subs, which is the cost of the sub, $3, times y, the number of subs sold. And so I'm going to set that equal to 233, which is what the problem says that the total amount sold is. Now we're looking at the problem and we're taking a look. We're saying graphing. Well, we want an exact solution, so we don't want a graph, right? Substitution? Well, substitution looks pretty good actually. Right? Why does it look good? Because we already have one of the variables solved for. Same as we did in problem number 5. Right? So let's go ahead and use substitution over here. We're going to substitute x plus 11 instead of y in the second equation, and that's going to give us 5x plus 3 times x plus 11 is equal to 233. We're going to distribute, and we get 5x plus 3x plus 33 is equal to 233. Then we'll combine like terms on the left side. We'll get 8x plus 33 is equal to 233. We're going to subtract 33 from both sides. And that's going to leave us with 8x is equal to 200. And then I'm going to divide by 8 on both sides of the equal sign and get x is equal to 25. All right, and what does that mean? That means we sold 25 pizzas. Okay. Now we need to find how many subs we sold. So how can we do that? Well, we can take our value for x and substitute it in right over here into our first equation. So we get y is equal to 25 plus 11. So y is equal to 36. So what is our answer going to be? The answer is they sold 25 pizzas and 36 subs. Put a box around that.